Right, good afternoon, I have to say, everyone. Thank you very much to the organisers for inviting me. My name's indeed Wim Mellers, and I'm going to be talking about holistic design today. What I will be doing through my presentation is I will start off a bit of where we are, but it's really also the aim to look at where I think we should be heading to. And throughout the presentation you'll find a various number of examples, which are examples that I picked from which I call my application domains. One is where I look at intelligent system design, and the other one is sustainability, so looking at energy generation management. So we're going to have a quick look at where we are currently, why we need to change, because it's always important to know why you need to do something, what is needed, how are we going to do it, and then I'm going to conclude. So for now, if we look at facing a problem or dealing with a problem, most often what we do is we focus on the problem itself, or a part of it, sometimes even subparts of it, and we tend to split things up very much because it helps us in a way to deal with it to a large extent, but that doesn't necessarily mean that we come up with a better solution, and that's one of the key points I want to bring across today. We design to fit environmental criteria, but quite often those environmental criteria are very limited, and one that pops to mind is economical. You have to do it for this budget, otherwise it's not going to sell or we're not going to make it. We often fear to look beyond that, and that's one of the things I think we will need to do in the future. And we also design it for one specific context, so we don't always think about something that will need to have a long life, may get used into different environments, etc., etc. Now, along the side, as you heard from the introduction, my background is mainly on chip design electronics, and so one part of my work lies in the area of intelligent system design, and as much as I specialized in digital electronics, I don't really believe they have a long-term future. May sound a bit contradictory, but so I'm going to take you through some of that journey. If people are interested in the more technical side of the story, and if you're local to London, I'm actually giving a more technical presentation next week in another venue in London, which is going to go into more of those details. But what I want to do, and I'm using an analogy here because I'm not quite sure what the spread of the audience is, but effectively, if you look at conventional computing, we're working with ones and zeros. And I'm going to represent these ones and zeros with black and white cars, and effectively we've got loads of them. And so if you look at our computers, then they consist of three main parts. We've got the processor, we've got the memory, and we've got the communication. And one thing to keep in mind is that this system was originally designed for logic and arithmetic functionality. Yeah? And so what we do in the processor is we take some of these cars either way, and we effectively combine them into another set of cars. So it's a bit like a garage. And then if you look at the memory itself, your memory is some kind of parking. You basically put a storage or put those devices there for a long term or for a short term. So it's either short-term parking, which is what the specialists would call your main memory, or you've got your long-term parking, which is your SSD, which is your hard drives, whatever. Yeah? So your data is basically in a particular location for a particular point in time. Your communication, which is what lies in between all of those, is effectively your roads, and that's why your cars are moving from one place to the other, so your data is moving from one place to the other, which can lead to very interesting pictures if you take it from a real road, and this is the M25 by night. So effectively what we've got is we've got a bunch of cars, either white or black, that's my ones and zeros, and then we've got three main components. And what we've managed to do is we've managed to split this up in a reasonably interesting structure. And for anyone who's a specialist, they will know that there's problems here. And you can kind of see that because my model kind of collapses. And that's what everyone calls a von Neumann bottleneck. If you'd ever go into the details of what von Neumann actually said when he introduced his architecture, then you would also understand that that's a pretty bad choice of name, because effectively, von Neumann did say you have to develop everything at the same rate. And that's the one sentence that we overlooked, because what have we done for the last decades? We've focused ourselves and all of our efforts on that one, the process, and we ignored most of the rest of it. So they haven't really been developed at the same rate. But that's a slightly different story. So why do we need to change? Well, if you look at developing a solution from a one-sided perspective, then you're kind of going to unbalance your ecosystem. So if we look at our computers, we've kind of unbalanced that ecosystem. We've put a lot of effort onto that processor. It's very fast, it's very good, but the rest can't catch up, so we've got a problem. And so there's other examples in that context are, if you're looking at systems like combined heat and power, and this is taking me to the renewable side, and then what we do is we effectively have heat and electrical output. And all the control for these systems is either focused on either the electrical output or the heat output, but never the combination of the two, even though we get both. Yeah. So, on the other hand, we do still sell these systems or we market them as in, they've got about 90+% efficiency. And that's based on using the heat and the electrical, but in practice we never use both. So we're actually selling something wrong to the customer, or we're selling something that's not delivering. Yeah? In practice, you never get to that 90%, you more closely get to the 60% because you haven't really developed your system properly. Yeah? So that's not really where we want to be, I think, or at least where we should be. So moving back to our computers, just a bit of evolution here. This is where we have been developing from the 1970s all the way to a few years ago, and then we've got the various things. So we've got our transistors, which is basically the amount of tools you've got in your toolbox or in your garage. You've got the single-threaded performance, you've got your frequency, you've got your typical power, and then you've got the number of cores. Most of you will probably remember that at some point our frequency was kind of starting to drop off. And that's exactly the point in time where they started to sell you the Core Duo and all the other ones. Yeah? Now the interesting thing here is that for most of these curves is you can start to see a trend. This is starting to flatten. We can still boost that up as long as we believe in Moore's law continuing, but depending on which articles you're believing, even that one's going to drop, finish at some point. Now if you then look at the market, and this is where it gets really interesting. The market basically was driven by desktop machines up to about a decade ago. And that's when they said, well, actually, there's not that much progress anymore, so they found another market, which is tablets and smartphones. And they managed to get everyone, or the audience, the customers, convinced that we all needed a new smartphone every year. So this is where you see growth figures going. No one still buys a new desktop machine every year because there is no need to it. You only chuck it out if it doesn't work anymore. Because there is nothing new to what you've got this year compared to what you had last year. That's completely different from a few decades ago. Now that sales figure on your smartphones is also dropping. No one is still buying a new smartphone every year. So it's going to be very interesting to see where the market is going to move and is going to try and sell us next. Because otherwise, this is going to be a dead-end slope like all the other ones. Yeah? So do we have challenges? Oh yes, we definitely do have challenges in technology. How are we going to solve them? Well, it's a very interesting question. Now, on top of that, looking at a very simple example and doing some very basic maths. So don't worry, you're going to be able to follow. YouTube has got about 300 hours of video uploaded every single minute. That's been their statistics for a few years now. If you look at storing that video, and I'm taking an assumption here, I'm assuming it's HD quality. Not all of it is, but we'll get there at some point. So, not too bad an assumption. That comes to about 1 gigabyte per hour. So, out of that 300 gigabytes per minute, I get to about 432 terabyte per day. If you put that in hard drives, that fills, well, that stacks hard drives the height of this room per day. This is only a minor fraction of all the data that's being produced per day, which is about 3 exabytes. And if you look at the rate per year, we're getting to about 1 zettabyte. And if you want to get a bit more practical to that, that's about 250 billion 2-hour HD videos. Not a person on this planet can ever watch all of those DVDs, trust me. Yeah? So, let's look at, because this is where I find it interesting, people say we're talking about big data. In all honesty, this isn't big data, this is huge data. Yeah? We're currently analyzing less than 1% of that. Yeah? And we're just creating at a massive rate because it's shooting up. That rate is increasing 60% per year. Yeah? So if we try to analyze that, again doing some simple maths, our 432,000 hours per day of YouTube video is uploaded by people who may or may not put useful keywords to that. And that's the way we search for it. That's the only way we can search for it currently. So if I want to get more out of that data, if I want to start analyzing it, I will need to get someone probably to sit down to look at that. Or I will need to have a system to do that for me. Let's first look at the human approach. I create a company where I employ people and they will be watching YouTube videos for 8 hours a day. Lovely job, you can discuss about that or not, but I will need a team of about 54,000 people. This is slightly bigger than Google is now. And these people haven't done anything with analyzing, they haven't had a lunch break, they can't be sick, they can't go on holiday. Not the most pleasant job maybe, but you can discuss that. So, YouTube is only 0.0001% of all the data being generated. Is this problem big? Yeah, it is. Can you get anyone out of unemployment? Oh, definitely. But we're trying to find technological ways to deal with that. If you then, and I haven't got that on the slides here, if you then start to do the calculations on doing this automatically with our current technology, and this is where I say, okay, if we're looking at human brain capacity, consumes about 20 watts to do what it does. If you use current technology to deliver something similar to the human brain, you're looking at 100K to a megawatt. And you're looking at a machine the size of a football field. If you compare that with the largest power stations on this planet, you're not even getting anywhere close to that 54,000, you're getting to a few hundred equivalent humans, I call them. This problem is huge, not big. So, what I wonder about is, why does no one in this big data industry has done the simple maths? Because you'd notice that none of this is working, and that we've got a problem which is much bigger than we currently can handle with. Yeah? And or why are they blind for the outcome? So I think we need to start questioning the way we design and also how we deal with things like creativity. So what do we need? Well, in a way, when we start to design, we can't just look at the problem that's just in front of our nose. There is more to it than that. Yeah? We need to consider all systems that will interface with what we're designing. So what's around it? What do we really need to look at in the bigger picture? And we need to consider things like what most people tend to call systems of systems. So you no longer have one thing that you're designing. You no longer have your CHP generator, but you have your CHP working in a context of a certain environment. You need to consider that environment and the required functionality. And when we're talking about environment, I'm really talking about the broader environment. And this is social, economic, political, as much as we may not like it, environmental, human, security aspects, sustainability aspects. And then you go, but that's a lot. How can one person deal with that? Well, this is where we need to look at things becoming not only interdisciplinary or multidisciplinary, but both. Because there is a subtle difference between the two. And so we need to find ways of combining that, and we also need to get this into education as a starting point. Because that's the only way you'll get people skilled to deal with the problems at that level. Yeah? And that's where we currently aren't at all. So what are the challenges? Well, we need to solve the problem. You may say, well, if we need to look at it at that scale, it's all going to be so difficult because it's so big. Possibly true, but I think unless we give it a try, we're not going to learn. And I'm pretty sure actually that if we start to learn that skill of looking at the bigger picture and zooming in on specific parts, and continuously doing that and get that into our education for people, we will actually get to a completely different attitude. And it may actually seem more natural and more easy than we think it may ever be. So when it comes to the multi and interdisciplinary work, I would say at least for now, there's definitely still challenges there when it comes to communication, when people have their specific jargon and they like to stick to it. If you can't explain your subject to a man in the street, sorry, it's something you need to work on. You may like your jargon, but you need to be able to explain what you're doing to anyone. So, something that we probably need to work on in a larger scale as well, even from an educational perspective. What I'd really be hoping that all of this will achieve as a reward is we get solutions that truly fulfill a bigger goal, and that they fit the market that we put them in and society as such, and that you don't have any doubt as into, is this going to work for 5 years, is this going to work for 10 years, or am I going to have to throw this away in a year because they're going to bring something new out? If we want to go for a sustainable future, then we need to start looking at all of that being incorporated. So, giving another example here, if you look at CHP, what we had, or what I started off with, was effectively you've got your CHP, heat electrical output, that's all you've got. And you've got some demand. Now, if you're looking at it from a system of systems perspective, you're looking at the bigger picture of this. You're looking at storage, deal with the excessive heat that you may not need at some specific point in time. You're looking at electrical storage to deal with any excessive electrical, because trust me, your CHP just gives you that constant output. Your demand is never going to be constant. It's always going to be fluctuating. So you need a buffering mechanism in the middle. This is where storage comes in. That's why we've got storage, so we need to deal with it. And you can also easily envision, depending on which technologies you're using, if I use compressed air for electrical storage, I probably need an interaction with the heat as well, and vice versa. So depending on which technologies you're using, you need that. Now, there are certain people who say that these days the technology is no longer the challenge, and I would kind of starting to agree with that. It's about bringing it all together and getting it work. Because most of the technologies to do that are here. We need to tweak some things here and there, but we can do it. But we haven't brought it together. And that's where the challenge lies. If I then look at, shortly, the puzzle around developing intelligent computers, which is part of what my group is working on as well, then there's a variety of so many different things around. Because as soon as you start to question one thing, which is the architecture, your processor, memory, and your communication, then actually most of the rest of that castle falls apart. And so you start to question, okay, do I need to look at how I represent data? How am I going to represent data? How am I going to store it? How am I going to deal with the interaction? How am I going to actually process it? Etc. And if you look at biological inspiration and you look at things like brain, it's got loads of feedback. But most of our systems don't have a lot of feedback. How do we deal with that? You know, if the brain claims to have more feedback than feed forward, we've never designed a system with more feedback than feed forward. So how do we deal with that? How do we look at creating this in actual technology? If we try to make something artificial, but still Well, neither than actual technology. You get into the ethical aspects of what part of the brain do we really want to copy? Which part do we really need? Yeah? Interesting questions around what's consciousness and subconsciousness, and what's the division between the two, and what processing happens where. Yeah? None of that can be ignored if you're trying to solve any of this. Yeah? So for me, I can't get my students to think wildly enough to incorporate all of that, because otherwise you can't answer that question, full stop. I don't want to end up with another von Neumann example, where down the line we've got something that actually worked a while ago and was designed for one thing, but now we're trying to use it for loads of other things and actually it doesn't work at all. Yeah. So how to do it? Well, I think the first thing is we need to get education to start opening people's mind rather than closing their mind. And with that I'm referring to the fact that if you look at a 3-year-old child, and the age doesn't matter too much as long as they're really young and they haven't gone into education at all, they are incredibly creative. Look at a child that's come out of education of about 16 or 20 years, so they're 18, they're 20. Creativity? Might want to work on it. Yeah? We as engineering educators, we struggle to get that creativity in our students. We've only got 3 years to do it, 3 or 4 years. Doesn't work in 3 or 4 years. But why is it out of them in the first place, is my big question. We need people to think out of the box, because otherwise we're not going to solve what we're facing. You can't keep repeating the same mistakes, because then you stay where you are. Yeah? We need to get people to think out of the box. We need to get a better handle on how we deal with that skill of zooming in and generalizing very quickly. It's a tough one, but there's got to be a solution to it. And how, in a culture perspective, how do we move away? And this is me speaking as an interest in sustainability. How do we move away from everything being economically and numbers driven? Sorry, it drives me mad. The only thing that counts is numbers. So what? We're people. Where's the community? Where's the, I interact with you. I'm a person just like you. We're all people. Yeah? I think we need to put ourselves a bit more central rather than these numbers. And we need to change things from a personal benefit to a common benefit. And here I'm talking about, I know there's diversity or difference here between cultures, but I spent a year in Japan, and I can tell you that's a completely different perception on what it is in most of the Western world. The Western world is egocentric. Sorry, mainly. I know a few exceptions, but they're exceptions. In Japan, you are part of the community. For anyone who's ever been to Japan, you will see that most, if not all people who have a job there have got a uniform there. The reason why they've got a uniform is because it makes them feel part of that community. And that helps, trust me. I haven't lived in a better and more friendly place than that country. So we have something to learn from one another. And I'm just picking up on one now as an example. We need to encourage and foster out-of-the-box thinking. Nothing is mad enough. Mad doesn't exist. Yeah? I see so many things being thrown out of the window. It's like, no, but that's not going to be accepted. So what? You haven't even tried. Most of the filtering that we do on ourselves and our thinking happens before it comes out of our mouth. Yeah? It shouldn't be. So we need a variety in ideas, and we need to challenge similarity rather than embrace it. Politically, I think we need to move towards long-term thinking. There is way too much short-term thinking. Oh yeah, I'm going to be re-elected in 2 years, or not, maybe not. Okay, I can't do that then, can I? So, does that help our nation? Does that help our society? No, it doesn't. That's one, it's the egocentric thing again, and two, there is no long-term thinking. Because if I can't do it in 2 years, it's not going to happen. No, I mean, I'm going to be living longer than another 2 years, I hope, and most of you as well. So we really need to start thinking that long term. And we need to kind of question the existing, and that includes going back to the basics. If I look at most of my research over the last 10, maybe 15 years, I have spent a lot of time questioning whatever we've got, and each time going one step back further to the basics for it to start to make sense. Yeah. So if we look at computers, and this is just throwing one idea out there as to why things can be looked at in a different way. We have our current structure with processes, parkings, our garages, parkings and roads. But why did we split them in the first place? We don't even need to. Because if you look at, you can use memory to do processing. That's what FPGAs do. Lookup tables, which are effectively true tables. And if you look at memory and communication, the only difference between them is your relative speed of the movement of the car. If you think about the parking, it's parked there temporarily. Your road, it's moving. Unless you're in a traffic jam, and again, you're parking. Yeah, so there's only a speed difference there, really. So in conclusion, a lot of our current designs form very narrow-minded solutions to a problem. Design solutions need to incorporate more of their environment, and I'm really talking about the larger environment here. We need to move towards multi- and interdisciplinary research, development, education, and a culture with less ego. It may not be the easiest path to walk, but we'll have to start at some point and somewhere, and I prefer it to be here and now, if not in the past. So this is a message for people to really embrace difference. Yeah? This giraffe is doing something different. That's why I like it. So thank you very much, and if there's any questions, I'll be happy to take them.
For the big data, you mentioned that there's a huge amount of data. What is your advice for the data mining community from your perspective?
Ooh, that's a challenging one. I know that they're doing certain things with the existing tools or whatever tools they've got. I think what currently is happening is very limited to what we can do in whole scale. From the way I see it is we can only recognize certain patterns or pick up certain things which are really minor to what probably we would like to do with big data. Now, actually what pops up in mind is big data projects are actually not more in any way more successful than other IT projects. And there's articles out there that say the standard rate of success is 30%, 30, which is particularly poor. So I think in a lot of cases, all of this data is just being stored. You know, hard drives are cheap. We've got loads of data centers, just chuck it all up there. However, that doesn't mean that we need to look for, it really means we need to find a solution to deal with it quickly if we want to get it out. Because there is use to this data. Do we need to use it all? Don't know. Do we need to think about privacy issues? Oh, definitely. Because in most cases we don't. And again, it's because we don't really educate people to deal with it or understand what's concerned with it. But I think we need to look at it from a larger perspective. So for the people out there working in the industry, I can only say go ahead, but be aware there may be a storm coming, and I hope it's coming soon. Any other questions?
Do you have implemented any model for this?
Models for?
For this, your garbage, parking, and communication for the 3.
Okay, so if we go now to the very specific stuff on the computing, where we are is we've been questioning this. So we've been questioning the data representation. in combination with processing and all the other bits, because it all hangs together effectively. At this stage, I've got one of my students looking at, a new type of data representation, and we are building up our model on how we do the data representation to get the processing right as well. That's where we are on that side. I've also got a few students working on machine learning, because obviously once you start to change the model of how you process, you may also have to change the model on how you learn, etc. And our main aim there is really to do the learning from a perspective of minimizing data storage, because you know which data you've got, you can decide which data is important, and you can therefore also make a better decision on what you need to keep and what you don't need to keep. So there's a variety of bits and pieces happening in that context. Most of it is still, I shall say, everything is still internal, because we've got some IP possibly related issues there. So we haven't published anything on that yet for that very reason. Yes?
Yeah. In the introduction, they said about energy storage and harvesting. So are you applying some biologically inspired energy harvesting techniques to solve such big problems?
Can I just clarify the question as into, am I working on biological principles as in technologies?
Yeah.
Or am I working on using IT-based biological principles to control the system?
For digital data representation, is it in connection with that?
Right, okay. The digital or the data representation we're looking at is aiming to go closer to what nature really does. So that's our real aim there. And that also, because there is such a close link with the way you process it, we're actually also looking at that from a processing perspective to get something closer to. Because I spent a substantial amount of time looking at how the brain functions, but then from a top-down perspective rather than from a bottom-up perspective. And there is actually commonality across a lot of theories. However, to achieve that functionality, we haven't got the right hardware. So we're looking at the processing principle to then also map onto the hardware that will allow us to deal with something which is much closer related to nature and physics itself. So you get a more direct way of computing effectively than what you currently have.
Excuse me, why you are calling current designs are narrow-minded? Might be these designs have some trade-off.
Well, there's always going to be trade-offs. The question is whether you put the trade-offs. I think a lot of the trade-offs these days lie in the economic factors more than anything else. And for me, it is, if you look at most designs that are created by engineers, they will have had the trade-off of economics. There is a few products out on the market where the company basically said to the engineers, you go away, you do what you want to do. And they're of a completely different style and nature than your standard off-the-shelf product. They generally come with a slightly different price tag as well. But we need to think about what we're doing. Do we really need to, we design most of our products to fail in a number of years. Is that sustainable? It only comes to the benefit of that. It's sustainable. Because we throw so much away, we will suddenly be living on waste. Because we won't know where to put it. And that's wrong. That's wrong. I mean, it's nice to buy yourself a new phone every year, but at the end of the day, once you throw it away after a year, where does it go? There's a limited amount of that stuff that gets recycled and can be recycled at all. So, I've never bought a new phone every year. I wear them until they really fall apart. and I do that for most of the products that I buy. But I still get disappointed that these products don't last any longer. Because do we have the technology and the skill to build a car that's going to last 50 years? Oh yes, we do. Do we build them? Oh no, we don't. And why? Because people like to buy a new car and we like to sell them. That's not sustainable. It isn't. It really isn't. So the technology is there as a set, but we're not using it in the right way. We need to think about us and the next generations. Because if you're not living on rubbish, it will be the next generations living on rubbish.
We have talked about that systems have fluctuations and there should be a buffer to control it.
Mm-hmm.
So there are certain systems like the generation of electricity and its consumption. So these are the systems where the buffer is not there, basically. It's not possible.
It depends on the scale you're looking at.
Yeah, I just want to know that in what context you are trying to.
So if you, when I'm talking about, and this is where I, if I wanted to go into one of these into more detail, I could have filled easy more than half an hour. But for me, electricity generation or generation in general shouldn't be as centralized as it is now. It should be localized. CHP systems are meant to work on a small scale. You have small hubs of energy production. This, if you do this on the right scale, and the question is on what scale, and that scale will depend on the context that you're working in. But if you do this on a small scale, you will bring communities together. Because people are suddenly responsible for their own energy generation. Yeah? So I'm going to talk to my neighbour and say, okay, do you have excess use? No? Yeah? Maybe? Because I have to. We're living together. We're living off the same thing. What we've got too much, to bring up another example, is we've got too much dependence on saying, oh, they'll deal with it. I'm paying them for it. I'm paying tax, so I expect my streets to be clean. Well, if you make me responsible for my street to be clean, it's going to be clean. If I pay tax based on that principle, I'm going to say, well, I've paid for it. Why isn't it clean? Yeah? So it's that concept in the mind that I think has gone the wrong way. And it's the same with energy production and generation. We currently live in a context that if I switch this on and it works, I'm happy. Yeah? And as soon as that's not happening, that's when I start to ask questions. Yeah? Or, in our case, mostly, we will just point at government and say it's not working. Yeah? In a lot of these, a lot of our energy generation companies, the big players, and I don't have anything against the big players if they play the game right, but they don't really play the game right in this case. There's a lot of cases where they put all transformers down, so they've got loads of equipment standing around, which they're not really maintaining right or to the right level. Yeah? If you as a company have social responsibility, which you do as an energy provider, then you've got responsibility to maintain, you've got responsibility to take the money and replace the equipment when it needs to. What happens is they let the equipment go all the way till it fails, and then because people fall without electricity, everyone starts shouting at the government. And what ends up happening is that the government pays for that equipment. Is that right? I don't think so. As a company, it's your responsibility to deliver, and anything that falls under that umbrella of the delivery. Not to go to government and then say, hey, but this has failed, can you pay for it now? These companies have gone running with the profit meanwhile, trust me. That's not right. It's not socially responsible in any way. Yes?
You very beautifully expressed about various views we should think on, not just focusing on the processing. So storage, processor and communication. Do you think it is also important to extend in the model, keeping in view the user's needs and these things, also extending this model? User-centric needs and these things.
Oh yeah, definitely. Yeah.
So when we extend it, the user itself can be thought of, because there are now user-centric computing and collaborative
definitely.
things that are coming.
Definitely.
So
Yeah.
they should also be there.
It should be centered from us. It shouldn't be centered from another's perspective. So the way I'm looking at most of our development in this area really is we're trying to we used to have what I call a processor-centric model. We're trying to move towards a data-centric model because your data is your main point. And that data will come from a variety of inputs and will come from a variety of different angles. For example, me as a human. But I also need to understand how I as a human will interact with that new technology. Yeah? To pick up another example which I've started questioning recently, a number of years ago we've invented something called email. I'm not sure how pleased and convinced people still are about email, but personally I'm not. Because at the end of the day, we've gone to a technology where you type everything out. Yeah? And I've got RSI, so typing for me is a challenge. The only benefit to email then is I can send a message to someone and they can pick it up when they feel like it. Whereas previously I used to pick up the phone and I speak to them immediately. Now, if you pick up the phone, 1, people aren't there. 2, they never get back to you even though they see they've got missed calls. 3, if you do manage to speak to them, they'll say at the end or at the start, can you put that on an email? In the old days where I spoke it was direct. Now I need to type it all out, which takes me a lot of time. It's not faster. It may be more convenient in the manner that other person can deal with it when she's got time, but it's not faster. So have we gone forward or have we gone backwards? Yeah? And if we really want to go forward, then what's our next step? Yeah? I'd like to kind of do brain-to-brain communication. It's quicker, faster. Yeah? Gets into a lot of ethical issues as well and other nice challenges, but why not? Why not think about it?
Apologies, I missed part of the presentation. Your brain is sort of mentioned in the model there. You also just mentioned brain to brain. Don't you have like a limited understanding of how the brain does actually work?
Yes and no. I say yes and no because there's a lot of different theories out there, and most of these theories start from a bottom-up perspective, meaning neurons. I was at the human, if anyone from Europe, you may have heard of the Human Brain Project, which is similar to the Brain Project in the US, etc. So it's all about the human brain, effectively. So I was at one of their conferences last week, and the only thing you hear is neurons. Neurons, 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 neurons. Now, I'm pretty sure if I asked anyone that presented there, can you exactly explain to me how a neuron works, not a single one would be able to explain to me. However, what we've managed to do in science and engineering, especially when we start to model these things, is we've taken some kind of model and we've built a whole castle on it. How can you build a castle if you haven't got a foundation? So, I'm not a believer in neurons. They're interesting to study, and do we really need to model them to the level that we need, we're trying to model them? No. Do we need to understand them at that level? Probably no. I want to understand how the brain functions from a top-down perspective. What does it deliver? How does it deliver it? And then if I've got those as lessons, I'll say, okay, now let's put that against technologies that we've got available and let's map that. So, have we got a good understanding of how it works from a bottom level up? No. From a top level down, there's various theories out there, and they have a lot of overlap. And for us, as for now, we actually know enough to get going. So, I think we can get somewhere. Right? I shall wrap up. So if you feel free to grab me over lunch or later.